Hello everybody, hope we're doing well. Today what we're going to be looking at is we're going to be doing some graphing and interpreting of linear functions. That's the next indicator that we are going to be covering in Unit 1. By now you should have already watched the interval notation video and you should have completed the interval notation quizzes online. If you haven't, please pause this video and go complete those two things right now, because you need the interval notation stuff in order to understand this. So that being said, we're going to get started. We're going to do this. So the first thing that we're going to have to do is we're always going to have to graph it first. So if you remember from Algebra 1, there is a formula that we like to use in order to graph lines, and that is y equals mx plus b. I'm guessing you remember this. B is going to be our y-intercept, and m is our slope. So what we're going to have to do every time is we're going to have to get our equation, which we see right here. We're going to have to get that equation in y equals mx plus b form, or we're just going to have to get y by itself. So how we're going to do that is we are going to start by, we're going to subtract 9x to both sides. So we're going to get 12y is equal to negative 9x plus 24. Then from here, we still need to get this y by itself. So we're going to have to divide everything by 12. And when we do that, we're going to get y equals, I'll put it over 12. We're going to get y equals negative 9 over 12. And we know that negative 9 over 12 simplifies to negative 3 over 4x plus 2. So what we have now with this equation, y equals negative 3 over 4x plus 2, we have our y equals mx plus b. So from here, we're going to be able to graph that. So the first thing that we're always going to do is we're going to plot our y-intercept with this. So our y-intercept is positive 2, and we know that a y-intercept of, sorry about that, let me erase that. We know that a y-intercept of positive 2 will be right here. Okay? So once we have our y-intercept, what we're going to have to do is we're going to have to show how our slope is behaving. So we know that another way of saying slope is rise over run. So we know that we're rising 3 and our run is 4, but it's negative. So that actually tells us that instead of going up 3, we're going to go down 3. So we're going to go down 1, 2, 3, and over 1, 2, 3, 4. And we could do the same thing in the other direction. So we could go up 3, 1, 2, 3, but then over to the left 4, 1, 2, 3, 4, to show that our line is a negative. So once we have a couple points, we can then plot it. Okay, so can make our arrows, because this will go on forever and ever. Alright, so now, once we have our line, what we're going to have to do now is we are going to have to interpret it. So, quick refresher on what domain means, okay? Domain is all possible, all x values. Okay? So if we think about this, with our line, we're going to see that this line, it goes on forever in any direction. So the x values associated with it on this number line, the x number line, can really be anything, because we know that this line is just going to go forever to the right, and this line is going to go forever to the left. So eventually, it's going to hit all of our x values. So we know that the domain is going to be from negative infinity to infinity. So we're going to have to write that in interval notation. So we know, based on the interval notation video, that when we associate infinity, we know it's going to be parentheses, because you can never actually get to infinity. So our domain is going to be from negative infinity to infinity. Okay? We're going to find that our range is very similar here as well, for the same reason. We know that this line goes on forever in both directions. So no matter what y value, right, y values are here, no matter what y value we get, we're going to hit them all, because the line's going to go on forever in both directions. So the range will be the same as the domain. It will be from negative infinity to infinity. Okay. So now we're at f of x is greater than 0. Okay? So f of x is really just another way of saying the output. And the output in our case is going to be y. So what this is really saying is, when is y greater than 0? So what I like to do, I think it helps to shade it. Shade where is y greater than 0. Well, if we shade it, y is greater than 0 everywhere that is green, right? It's going to be everywhere from this point right here, because that's when y turns from being positive and greater than 0 to being 0 at 3, and then eventually it's going to become negative based on our line. And if you wanted to see that, you could just pick any point on the x-axis and just go up to see the y. So we're going to see that everywhere in the green is where y is greater than 0. So what that is, it's going to be from negative infinity to 3. But we need to think about, is 3 going to be included in our interval notation? Because that's going to affect what set of parentheses we use. Well, if we think about it, this is asking, when is y greater than 3? So at the point 3, which is right here, is our y greater than 0? I'll give you a second to think about that. Well, the answer to that is, no, it's not greater than 0. Our y at the point 3 is 0. So, because it is 0 and not greater than 0, we're going to use a parenthesis, because the 3 is not included in this notation. Okay. Next up is we have, when is f of x equal to 0? We know f of x is just another way of saying output. So what that really is saying, when is y equal to 0? Well, we know that y is equal to 0 at this point, right? It's our x-intercept, and the y here, we don't go up, we don't go down, it's on the x-axis. So that's telling us our y is 0, right? So we know that the y is this line. At this point, we're not up any, we're not down any, so y is 0. So, how we're going to write that, it's at 3. So, and it's only at 3. So, we're just going to write 3. And why would I have used square brackets? I use square brackets because the 3 is included. It's the only point that is included. All right. Next up, I'm going to change my color just to help see it. We have, when is y less than 0? I'm a big fan of shading graphs, especially when we're just getting started, so that we can kind of see when where is y less than 0? So y is less than 0 if we go from the x-axis whenever we go down, right? So we go down there, we go down there, we go down there, we're going down, right? So in purple is going to be everywhere where y is less than 0. And remember that this line is going to go on forever. So it will hit all the x values as we go to the right. So we know that the point where it goes from being positive to 0 is at 3. So 3 is going to be where it starts to become less than 0. So this is going to be from 3, and then it's going to go forever to the right, right? Because this line is going to keep going down, and all those y values will be negative from 3 to the right, because that's line going to keep going down. The y will never be able to come back up and be positive. So it's going to be from 3 to infinity. And we're going to use a parenthesis because we know that infinity, you never actually get there, so it's not going to be included. All right. Finally, we got the last two things, and these two things go directly with each other for right now. So we're asking, when is our line increasing and when is our line decreasing? Well, with linear functions, the line only goes in one direction, so it can't be both increasing and decreasing. So if we take a look at it, what is our line? Is our line increasing or decreasing? Our line's decreasing. So what that's saying is, for what x values is our line increasing, and for what x values is our line decreasing? Well, the x values where our line is increasing is never. So we're just going to write never. And then the x values to where our line is decreasing is all x values. And how we write that is like how we did it in the domain. So from negative infinity to infinity. Awesome. So that's pretty a typical problem for graphing and interpreting linear functions. What we're going to do is we're going to answer a quick question about the x-intercept, and then we're going to do one more example. If you feel like you want to try the example on your own, I will scroll up and you can pause the video right here and you can give this one a try on your own. Alright, so welcome back if you're back. So what we're going to do first is we're going to do the challenge. If we were given just the equation above, how could we find the x and y intercepts? So what we could do is we can plug in 0 for x or y. If we were finding the x-intercept, we know that our y would have to be 0. So if we think about it, our x-intercept is here, right? And we know at this point, we're not going up any, we're not going down any. Y is at 0. So all we'd have to do for, if we wanted to find the x-intercept, is plug in y as 0. And then solve. And it's going to be opposite for the y-intercept. If we wanted to find the y-intercept, we know that it's nowhere left, it's nowhere right. It is at 2. So what we'd have to do is we'd have to plug in x to be 0 to find the y-intercept. So what we would say for this challenge is we would substitute zero in for x or y. Okay. So what we're going to do now is we are going to solve this second example problem. We're going to do it the same way. The first step that we're going to do is we're going to need to get it in y equals mx plus b form. So in order to do that, zoom in a little bit. We need to get y by itself, so we're going to have to add 6x to both sides. Add 6x. And we're going to get negative 3y equals 6x plus 12. Then we're going to need to divide everything by negative 3. And we are going to get y equals negative 2x, let's divide by negative 3 as well, minus 4. Alright, so now what we're going to have to do is I want you to find the x and y intercepts based on the equation we just found. We know our y-intercept because it's in slope-intercept form, and we know that the b is our y-intercept. So this negative 4 is going to be our y-intercept. What we just talked about, if we wanted to find the x-intercept, we know that the x-intercept is going to be, x-intercept is going to be somewhere on this line, and we know that on the x-axis, our y is always 0. So if we wanted to find the x-intercept, all we'd have to do is plug in 0 for y to find it. So we'd get 0 equals negative 2x minus 4. We'll write that out. We're going to change the color so we can see it. 0 equals negative 2x minus 4. We're going to solve that. We're going to add 4 to both sides. We're going to get 4 is equal to negative 2x. And then x is equal to negative 2. So we know that negative 2 would be x-intercept. So we're going to graph this line. Keep pressing the wrong button. We're going to graph this line right here, the y equals negative 2x minus 4. So our y-intercept will be at negative 4. And we know our slope is negative 2, so it's going to go down 2 and over 1. So down 2 and over 1. And it's going to do the same thing in the other direction. Up 2 over 1, up 2 over 1. And you see that our x-intercept does match what we just found, which is how it's supposed to be. By finding the intercept, it's really just another way to double check that you're right. So once I have a bunch of points, I'm going to graph them. I'm going to keep extending that up, just so it'll help us when we do the where is y greater than 0, etc. So we're going to do the domain. We know that domain is all possible values for x. So we know that this line is going to go on forever in both directions. So eventually, this line will go forever and ever up and over. So it will hit all x values this way, and it's going to do the same thing going the other way. It's going to go forever down and to the right. So eventually, it'll hit all x values to the right. So our domain is going to be from negative infinity to infinity with parentheses because the infinities are not included. And then our range with all possible y values, and for the same exact reason, because our line is going to go on forever, it's going to hit all possible y values as we go to negative infinity and we go to positive infinity. So it's going to be from negative infinity to infinity. All right. Next up is, I'm going to change my color. We're looking for when is y greater than 0. I always like to shade this. Okay, so y is greater than 0. Right, y is greater than 0 on this axis, right? That's where y is greater than 0. And based on our line, that is in this region right here. So we're going to shade that region. And we know that this line is going to go on forever, so it's really from our point of negative 2 forever to the left. So how we're going to write that, where y is greater than 0 is going to be from negative infinity to our x-intercept at negative 2. And we know that we're going to use a parenthesis for negative 2 because at the point negative 2, it is 0, not greater than 0. Then we know, where is y equal to 0, or where is f of x equal to 0? Well, it's equal to 0 at this point right here. Right? It's at our x-intercept. We're going to write that just like how we did in the last one. We're going to use square brackets, negative 2. Okay, now we're asked when is f of x less than 0. I'm going to grab a new color and I'm going to shade. Y is less than 0, starting here and going forever to the right. Right, because all these y values on this line, if we just connect it to the line, all these y values are negative. And this will go on forever. So it'll be less than 0 from negative 2 to infinity. And we know that these are both going to be in parentheses because the negative 2 at x is negative 2. Our y is at 0. Our y is not less than 0 yet. And then finally, we know based on looking at our line, it's decreasing. So it's never going to be increasing. And it will always be decreasing, and we write that as from negative infinity to infinity. I understand that this is going to be pretty new for a lot of you, so give the practice a try, and please, please, please ask questions. Wednesday, we're going to have some office hours, so as you're doing the practice problems, please write down some questions you have. Feel free to send me an email with those questions, or you can ask the questions in the Google Meet tomorrow. I look forward to seeing your work, and have a great day.